For the last lesson of the chapter, we're going to talk about infinite geometric series. And we're going to find sums of those infinite geometric series. In particular, we're going to find the sums of infinite geometric series having ratios with an absolute value less than 1. So let me give you kind of an example here. This is just going to kind of illustrate a point. Let's say we have this geometric series. Let's find the first couple sums. Let's not do all of them, but let's find a few. So I can tell here that my common ratio is 1/2. So S1, if I just added up all the terms up to 1, just 1/2. For the sum up till 2, I would add 1/2 and 1/4. And so I would get 3/4. And then if I add up the first 3 terms, 1/2 plus 1/4 plus 1/8 equals 7/8. And then so on and so forth. Let's kind of skip ahead here. Let's do the sum up until 10. For this, I'm going to use the formula because I don't want to have to find out all the first 10 terms. So I'm not going to show all my work here because we've done this in previous lessons. But if we did this, we would get 1,023 over 1,024. So as the n gets larger, what's happening? We're going from 1/2 to 3/4 to 7/8 to 1,023 over 1,024. That's really, really close to 1. So our series is getting closer to 1. So keep that idea in mind. We'll go to the next slide. So we saw then that geometric series was converging to a specific value, to the value of 1. Converging means it's getting really, really close to that value. So much so that we can just say that it converged to 1. The sum was equal to 1 because it's going to be getting so close to it. So that won't happen in all cases. Not all geometric series will converge to a specific example or to a specific number. So for example, this one here, that's just going to keep getting larger and larger forever. It's going to go to infinity. So there's no way of saying, oh, this is going to just equal 1 when I add everything up or equal a specific number, because you're going to keep adding to infinity. So if we read here, it says, in order for an infinite geometric series to have a sum, the common ratio must be between -1 and 1. So in order to get an example like we saw on the first slide, our r has to be between -1 and 1. It says, then as n increases, r to the n gets closer and closer to 0. The fact that r to the n approximates 0 for large n is used to prove the following theorem. So here it is, the theorem that we're going to need to know. We can find the sum, again, as long as the absolute value is less than 1, using this formula. The first term divided by 1 minus the common ratio. So let's put that into practice. Example 1 says, for each geometric series, find the sum. If the series has no sum, say so. Okay, so this is a geometric series. The first thing I want to do is find the common ratio. Here I can see that that's 1/2. Now, that is between -1 and 1. So I know that the absolute value of r is less than 1. So check, we're good. We're definitely going to have a sum. So the formula is S, and I'm going to just put an infinity sign for my subscript there, meaning we're not summing up to a specific number of terms. We're summing all the terms. And that's the formula T1 over 1 minus r like we saw on the previous slide. So the first term is 100 over 1 minus 1/2 equals 100 over 1/2 or 200. So if we were to add up all of those terms to infinity, what would happen here is that each number is getting smaller and smaller and smaller and smaller, so much so that they're so small, it's like we're not adding anything anymore and we converge to a specific number. Example 2, same directions. This is a geometric series. My common ratio is 3. This is not between -1 and 1, so there's going to be no sum. Basically, if I tried to add everything up until infinity, I would just go to infinity. I'm just adding bigger and bigger numbers forever. So this one is no sum. Let's try again with another example. Example 3. This is a geometric series. Our common ratio is negative 1/3. That is between negative 1 and 1. Its absolute value is less than 1. So we can go ahead and find our infinite sum by taking the first term and dividing it by 1 minus r. So the first term is 81 over 1 minus negative 1/3. So yes minus a negative is 1 plus 1/3. And we're going to get the fraction 243 over 4. For the purposes of this lesson, anytime you can write it as a fraction, anytime your calculator will give that to you, you can just go ahead and leave it as a fraction instead of a decimal. Example 4, same directions, find the sum. If there isn't one, say so. So this is the same thing, it's just in sigma notation. Notice it's telling you to sum, that's what the sigma means, from 1 up till infinity. So you're summing everything. That's how you know this is an infinite sum. So you're going to use the same formula. First term divided by 1 minus r. And it's just a little bit more work to find the first term, but that's about it. So T1 is going to be when I plug my n equal to 1. So 4 times 1/3 raised to the first power for my n. So that's 4/3. So I plug that in, so I'm going to get this infinite sum is 4/3 over 1 minus r. Now, you may be asking yourself, what's the r? The r is that common ratio. Think about if you did a couple more terms. So the first term you got was 4/3. If then you did the second term, so to the second power, then that's multiplying by 1/3 again. If you did it to the third power, that's multiplying by 1/3 again, the fourth power, etc. So each time you up the number term, you're multiplying by an extra 1/3. So your r then is just 1/3. So it's going to be 1 minus 1/3 on the bottom. Let me do it that way. So in the numerator we have 4/3. In the denominator we have 1 minus 1/3. So that's 2/3. So you have 4/3 divided by 2/3, which is the same. You don't have to show all this work, but just for now I am. It's the same as multiplying by the reciprocal. So you get 4 over 2, or just 2. Okay, here's a good word problem. It says, suppose Tim is walking his dog who starts to chase a squirrel. If he starts out from home, walks 1 mile east, then a half mile west, then a 1/4 mile east, then 1/8 mile west, and so on, relative to his home, approximately, where would he end up? So basically what's happening, I'm just going to kind of sketch a picture, is he's starting out from home and he's going a mile east. And then a half mile west. He's just kind of running back and forth. And then a 1/4 mile east. And then an 1/8 mile west. And he's going to just keep doing that forever and forever until eventually he's going to just be turning around in his spot. So the question is, where would he end up? How far away from his house? So what we have here is a series. So he starts out going 1 mile east. Let's call that 1 in the positive direction. Then he turns around and goes a half mile west. Let's call that the negative direction. Then he goes a 1/4 mile in the positive direction, then an 1/8 mile in the negative direction, and so on and so forth. Now, this is a geometric series. Our common ratio would be -1/2. That ratio is between -1 and 1, so we know that our series will converge. So, infinite series. We're going to take the first term, divide it by 1 minus r. The first term was 1. We're going to divide that by 1 minus -1/2. So we'll get 1 over 3/2 or 2/3. And that's positive, so we end up 2/3 miles east, remember it's a word problem, you need units, of his home. Okay, that's it for examples with this video, so go ahead and try the homework for 11.6 on Schoology.